Welcome back, everybody. In this video, I'm making the first installment in a series, or at least I hope it'll be a series, called More Stable JavaScript, in which I will express to you the different things that I've learned that has helped me write more stable JavaScript programs. And in this first one, I'm talking about type theory. Now, first of all, why might we care about type theory? I propose to you that the reason you should care about type theory as a JavaScript programmer is that the JavaScript engine itself rarely cares at all about type theory, so you have to care for it. And what do I mean by that? Well, we've all probably at some point been in a situation where we've done something like this. We accidentally feed a bunch of characters into a type coercion. This one's an explicit type coercion where I'm strictly saying make X a number. But oftentimes implicit, which is even more tough to, even more difficult to catch, it's even less obvious of a problem, is that JavaScript doesn't care and it doesn't throw an error. Instead, it just gives you this bogus value. So if I run this code, it doesn't say, hey, we think you messed up because you tried to turn something that can't be a number into a number. It actually provides you with this naughty number value. And it's still the same array. And if this happened as step one in our program would run through the rest of the 2, 3, 5,000, however many steps there were, and it would just keep passing nan all the way through, even though we thought these were going to be real numbers. So that's not what we want. Now, if we make the really obvious joke here, and we append Batman to the end, besides making a terrible joke, we actually do something else. And this is the implicit type coercion. So instead of having a string or an array of naughty numbers, we now have a string of comma-separated naughty numbers, followed by a space, and then Batman. This is implicit type coercion, where we didn't explicitly say, hey, make this into a string, like we did here, where we said explicitly make this character into a number. We used this concatenation symbol, which also doubles as the addition symbol in JavaScript, to combine it with a string, which the engine then just said, all right, we can work with that. We'll just make everything into a string. So none of this is what we want. And what we would really prefer is for the program to just throw us an error. So one of the things you can do, this is, again, you being proactive, the program's not going to care, is start adding comments and just say a basic type declaration for what you want your program to be doing. So in the, I would actually have to break this out. So let's call it make number. And it's just going to be type of, takes a string and it returns a number. So this will be let's make number. Function takes a string, and I'll just keep it exactly the same, and it returns number. Like that. And so again, this has no effect on the compiler, but one thing that I've found when making these very explicit statements in my code is it forces me to address any assumptions I have. So if I look at where I'm calling this function, I check letters, I realize, okay, letters is a string, can it actually become a number? Maybe this is buried a few lines deep in my function and I don't really notice that it returns a number. Well, if it says right at the very top of my function what it's going to return, and I know that A can't become a number, I'm not going to run this function over the letters array because it won't make any sense. Now, let's take a quick dive into type theory to explain why we got a nan. So, I'm doing this on a trackpad, so forgive me if it's a little janky when I try to do this, but what we have here is a group of elements, a set of elements, and another set of elements. One is numbers, and one is letters. These are our types in JavaScript. So back here, we've got string. These should really be string values instead of letters. So we've got our string values and we have our number values. And so this has every number you can imagine, and this is every string that you can imagine. So when we have a value like the character 5, it has a function that can point to it, or an arrow that can point from the character 5 to the number 5. And if we had the number, or the characters 1, 0 that make up 10, and we convert it into a number, there is an element in the numbers type that is going to correspond with that value. Likewise, if we had the number 6 and we convert it into a string, it will become the character 6. So we understand how this works, right? It's a two-way flow. The reason why this matters for JavaScript is that instead of doing what it probably should do, if we have a character A and we tell it to become a number, it should say, hey, there's no arrow that goes from the character A, which is an element in the strings types, to an element in the numbers types. There should be no arrow, but there is, and it points to our good old friend nan. So everything that doesn't have a matching value ends up just going to nan. So this arrow then exists for every other value. So if we undo that. So if we have a value, like I said, of A, and it's at this end, it points to nan. If we have a value of my name, Nathan, it's going to become nan. So that probably shouldn't exist, but it does. So we have to deal with it. And that's how pretty much all types in JavaScript tend to work. They give you some sort of bogus filler value that ends up being populated in your program instead of the program just crashing and saying, hey, we can't do that transformation because the element does exist. And this also explains to everybody who likes to complain about it why there is, or why nan is a number type, because it's essentially the bogus type in numbers. So not a number is a number because it exists in the number type. It's an element in the number type. Makes perfect sense. I don't know why people get weird about it, but they do. So that's why. So what does that mean for us? Well, if we're doing basic functions like this, that we know it takes a string and then it returns a number, this works really well. Maybe though you have a function that is going to return or is going to take an array of strings. You can write it like that. Or an array of arrays of strings, then you can write it like that. And the benefit is that you can then do a quick look through your code and start seeing all these type declarations. And if you are later editing your code and you decide that you don't want this to actually do a type coercion to a number anymore, and you remove that, it's just going to return this. In this case, it would do nothing. But if we had some other transformations that were occurring and then we were returning it, we need to make sure that this value at every point is still a number, because that's what we're promising to return. And for me, this has worked really, really well, because if I have a composition of a bunch of functions that are all making up a transformation of data in my program, and say it goes from being, I'll just write it here. So let's say my entire program looks something like this. It takes an array of strings, and then that gets transformed into just arrays of strings, which then becomes an array of pairs. Sometimes I write pairs like this just because it's a little more obvious. Pairs that would be a string and a Boolean, and then that becomes an array of objects, and then those become, let's say, network requests or HTTP requests that then return a Boolean for whether it was successful or not. Let's just say that. Well, if I then hop into this function, which is what this arrow stands for example, this transformation, or it's called a morphism, if you want to get nerdy. If I jump in here and I change this value so that this arrow no longer returns just an array of strings, it now returns, say, an array of strings. It just does some sort of transformation. then I know that I need to then step in and fix this, because my next function is expecting an array of strings, which means I would have to add a new function in there that transforms it into just an array of strings. And it becomes a really easy way for me to avoid writing functions that break all of my code, because they have to be consistent. So it prevents you from doing things like this. So if we had, I'll just call it func1, just because I'm just going to do some pseudocode here. But if we had an if it has this particular thing, then it returns true. Otherwise, it returns false with some reason. Well, then when we go to do our type declaration for this function, we say, all right, well, it takes, let's just call it val. And this, so it takes a value, and it's going to be a number. And then it's going to return, well, now we have, it either returns true, or it returns false, so that'd be a Boolean, or it returns an array or a pair that has a Boolean and a reason for the failure. Well, we can't do that in one type declaration, because that would be two different return values. So it makes you aware of what you're returning in your code. And JavaScript, like I said, does not care about this. If in some other programming languages, if you try to return different values, it basically says, you broke a promise to me. You promised to return this, and you didn't, so I'm going to throw a compilation error. Whereas if you're passing the return value of this function into another function, it probably shouldn't be taking either a Boolean or a pair of Boolean and a string. So you have to make a decision which one makes more sense. And in this case, I'll say, all right, I'm going to audit my code, and if it just returns true, if that's all I actually care about, I don't care what the reason is, because there was no reason for a failure, then I just have to give it the empty string value. And then the next function could say, check the Boolean, and if false, console log out the reason. Otherwise, if true, continue on. But you know that your types are consistent, which would look something. You could do it like this. Or if you prefer, like this, so that you maybe don't think that it's a array of Boolean string alternating or something like that, just make it consistent with your team, or if it's just you, your own style. So one other thing that might come up in using this sort of static type declaration is, what if you have what's called a polymorphic function, which needs to take more than one type? So if it's not just taking a number, it also could take a string, for example. You can't overload functions in JavaScript because it actually doesn't do any real type checking. So you don't need to overload a function. You don't need to say, hey, if it's a string, do this. If it's a number, do this. You would have to do that with actual if-else statements and type checks manually. But sometimes it actually does make sense. So for example, if I make a function called head, and it's going to take an array, so I'll just say it's a function that takes an array, and then it returns the first value in the array. I'm not going to write out the if-else just to check that it actually has a value, has a length, but you could do a type check or a check just to make sure that it has at least one item. I've done that in past examples in earlier videos. But in this code, we actually don't care what type of array we have. So if I were to do something like this, it could then return a string. Because I have an array of strings, it returns a string. Well, I'm not going to write a different function for every type of function, or every type of array I could pass in, because that's pointless. I'm not going to write head string, head number, head array of arrays, array of objects. Right? That's just pointless, right? What we do instead is something that you'll see a lot in type declarations. Type of A returns A, and that's actually a mistype. It should be array of A, whoop, returns an A. So all this says is that whatever value, whatever type is passed in, so whatever exists in here or in here, I'm going to pass back an element of that type. And that's all you need to say. So that if you're passing in, you know that no other transformations are occurring. You're not changing the value. So if you pass in an array of strings, you'll get back a string. If you pass in an array of numbers, you'll get a number. And again, this encourages you to think in a statically typed, more thoughtful way, so that you're not just mixing and matching types. Because if you pass in an array of numbers and letters, well, then what are you going to get back? You really don't. It depends on what the first item in the array is, and then that no longer works. Which means at that point you would be passing in something that instead looks like, I'll just give myself some space here. Instead of passing in just an array or passing in just a number or a string, you might think, okay, well, maybe I should clean up this mixed array a bit and have an array that has pairs. So you have like, I'll do it in actual JavaScript code. So A and 1. And then another pair that would be B and 2. And so on and so on. And now each pair is of the same type. It's a pair of a string and a number, a string and a number. That's a type. So then that matches type A and it returns type A. So you know that if you pass in an array of pairs of string and number, you'll get back a string and a number. And it just allows you to write functions that aren't going to do, like I said, funky things in your program without throwing an actual runtime error, which is what you would prefer. So it was a bit rambly and all over the place, but I hope this gave you some ideas about how you could think about your own code. This is how I personally think about my code. Writing my functions as if I had to statically type them, and that if they're polymorphic, I have to think of them as polymorphic, whereas if they're not polymorphic, then I have to think about the exact type that's being passed in and the type that's being returned. It makes for nice, stable, easily composed functions, which, if you've ever heard about function composition, it's how you manage complexity. So managing complexity is what we're always trying to do. I encourage you to do it. I will hopefully continue this series as I get some more feedback on these videos, and I will see you in the next one. So if you're watching this right now, and I will see you next time. Bye, guys.